This is actually a presentation that I did for grade 12 class, and I just modified it a little bit. They did a tour of the house, and then I did this presentation a few days later. So my son was in class, which is why I brought it to him. So a few of the features of the Verico home that make it an energy efficient house are compact design, good envelope, passes solar, just kind of it's a number of other things. And some of these can be modeled and some of them can't. Some of them are easy to model, some of them just happen, and others don't. And we'll talk a little bit about that as you go through too, I think. So this is the slide we should probably spend a little bit of time on then, what Hot 2000 is. Basically, it is it does an energy balance on the house, or building, or whatever it is you're modeling. Let me have somebody else here. And by that I mean it uses the characteristics of the house. So you enter the model of the house, the insulation levels, the type of heating system it is, the type of windows you've got in it, the thermal mass. The more detailed and the more accurate you can be, the better your model is going to be. Although to spend a whole bunch of time on it is probably not really worth it either, because the weather's going to be different. So you can make it spend all the time you want, make it as accurate model as you want, and it's still going to may or may not be what happens in that particular year.
The Hot 2000, it's government of Canada program.
Yeah.
But it uses all the same weather data that screen uses that.
It doesn't actually.
Uses them.
They're very similar, of course, but it doesn't use exactly the same database, which can be some problems as well. So we've just kind of started into this. There's not very many of us, so we're just going to do it pretty uniformly.
Okay.
I know a bit about these two guys. So
my name's Rod Orr, and my wife and I are looking to build out at Cerelia this spring. Hopefully we'll start. So we're just into the initial design stage and well, the good stuff that comes with that. So we've known Ron and Gwen for a while now.
Okay. Orr, you said?
Orr, yeah. That's
a pretty standard name, or well-known name in this particular field. So we're related to Harold Orr then?
No.
No? Okay.
No, if it is, it's coincidence.
Okay. Harold Orr was a guy that worked for Saskatchewan Welfare National Research Council, actually.
Right.
He retired before he became part of Saskatchewan Research Council in the group behind me. So he's kind of one of the grandfathers of this stuff.
Well, I doubt we're related because I'm originally from back east, so
okay.
I don't think I have any family over here.
Okay. Just a coincidence then.
Yeah.
So, and actually history-wise, the very beginnings of Hot 2000 were actually Robbie Mont's work. He went home one night and as the folklore says, he basically wrote the beginnings of Hot 2000 overnight. He just kind of Excel spreadsheet, basic whatever it was he used, because all it is an energy balance. Just take the energy that's coming in and use the equations and figure out what where the balance is. So it does use weather data, including temperatures, wind, solar radiation, and you can adjust all of those. So if you wanted to make it exactly the same as red screen, you could grab the red screen data and dump it into Hot 2000. It's easier to go the other way, but you can do it. It also uses, it tries to account for some of the occupant habits that you have. So like it allows you to enter, 2 adults, 2 kids, 50% of the time. That's kind of the standard. So if you're modeling a house that you knew there was going to be a couple and it was a smaller house, then you change that. It also has some defaults that it uses for appliances. If you know that you're putting in some better appliances, then you can reduce that a little bit. The thermostat setting is adjustable. It doesn't, however, handle a setback. It doesn't allow you to put a setback in. It does a monthly energy balance. So if you're going to put a setback in, setback's usually much finer detail than that. So you just put in an average temperature. So if your daytime is 21 and your nighttime is 19, you put in 20. It doesn't handle quite a few things though as far as occupant behavior is concerned. So it doesn't handle the fact that you've gone on vacation for a couple weeks out of the year. It just assumes that it's two adults, 2 kids, 50% of the time for the whole year. Or if you happen to have 15 people or 20 people in the house every weekend, it won't handle that either. Not to say that you can't, adjust those numbers a bit, if you know that that's what's going to happen. But the fact is, if you can predict what's going to happen for the next 15 years in this house, what all the weather's going to be, you probably shouldn't be in this business. You should be doing something else. A lot of the heating systems that are going into low energy houses nowadays are solar combi systems, and Hot 2000 doesn't handle that. In fact, there isn't really any simulation program, readily available simulation program that will handle combi systems. Polysun does a little bit, but it's you pay for it. The free ones basically don't handle it. And of course, it doesn't handle the variations in weather from the current year. Any more any sort of specific questions on Hot 2000?
I think the data that was presented for the Verico home had like the model of the balance, and it was on a monthly basis. And I was looking at the data there, and I'm trying to remember whether, I think it was the PV output was varying through the year, but then when you'd expect it to peak, it went actually down in July or something like that, and then the months either side of it were higher, and I don't know, is that something that's typical, or is it just the number of days in the month, or?
Part of it is the number of days in a month.
Yeah.
Certainly, June has one less day.
Yeah.
So you'd expect it to be a higher one, yet it would be because it is shorter. The other thing is that if your PV panels are at a relatively steep angle, like they are here, then the sun is actually going to shine down on them. Let's see if I can get this. So if you're fairly steep angle, the sun's going to shine down on them at an angle. Whereas earlier in the year, when it's October, September or May, then you get it more direct. So you actually end up with more solar radiation in the plane of the collector.
I think energy load changed as well on those. Yeah, so maybe something I haven't, because I don't have the data that was put into the model. I don't know what's changing in those months. So.
In the graph I saw, I think there were some typos as well.
There's some typos. Is that
Well,
that happens.
there was one value where like everything was, I can't remember,
The same.
three digit values.
Okay.
Like, and one of the months the number was 2. I can't remember what that.
Okay. Something didn't make sense to me, and that's what happened.
Okay.
Because this one is so limiting in terms of what you can do, are there better options in terms of software that are user-friendly that non-experts can use?
Hot 2000 is actually pretty good.
Yeah.
I mean, there are limitations, but it has an awful lot of features. It's actually a pretty complicated model. I forget what the total number of entries is. It's well over 200 items that you have to enter, on an average house, which is quite a few. It allows you quite a bit of flexibility. There's a few things that you can't do, but for the most part, you can get around them. Anybody who's done enough modeling can do some adjustments to you can't do a solar combi system, so you do